Guys, uh we're gonna jump into the first question. So I'm gonna do the whole matric paper from last year. Um what I did was, I think I did like question 5 and then I jumped to Euclidean. So what I'm gonna do is finish up Euclidean and this one, and then go back and do, because what happened was stats is question 1, and like I said, it's really hard to do stats without me having the calculator to show you. You can still do stats without a calculator, but having it like those calculations, just having to fill in the data and the calculator does the work for you, is way better than like having to do them your own, because prone to mistakes, all that. So if you input your data correctly, you're probably gonna get all the marks, but if you input your data badly, you're gonna get the marks wrong. But it's more better than you not inputting your data and calculating the mean and mode and all those things without your calculator. So that's why. So like I said from my last video, that Ella can use Mathematica or Octave for me to do a demonstration. Tell me if you can. But if I could get a calculator app that could be on my screen so that I can show you how to do it, that would be nice as well. Yeah, if you don't have a calculator, there is a calculator app that you can download on your phone, but it's probably best to buy a calculator, cashier calculator. Without further ado, let's just get into it. Yeah. So the first question says, given the identity that, so we know that this identity exists from the cos, cos A minus B. So cos A minus B is that, and then they're like, use the compound identity given above to derive the formula that. So don't write the identity, use the one that is above to get the answer. So let's jump into it. 6.1, right? Oh, 6.1. Yeah. So okay. So what we're gonna do, we want this to resemble a positive, and the only way it could resemble a positive is if we write cos of x minus y, that would equal to cos of x plus y, and we're gonna treat this as its own function. So what do we know? We're given that cos of that, so it'll be cos x cos minus y plus sine x sine minus y. And cos of minus 1, negative angles, remember, it's just on the Cartesian plane, it goes clockwise, so negative angles for cos are positive, so it would be cos x cos y. Negative angles for sine are negative, so it would be cos sine x sine y. Yeah, 2 marks, decent. We don't know if they want the substitution, yeah, but yeah. And then they say hence show that equals to tangent of x plus y. So it's an identity, and yeah, so tangent of x plus y, I would want to show that this would equal to, because since we don't have any tangent here, we want to show this is sine of x plus y over cos of x plus y. That's what will take us back to tangent. So let's write the information down. We have cos 90 degrees minus x cos y plus sine minus y cos 180 degrees plus x over cos all over oh my god all over cos x cos 360 degrees plus y plus sine 360 minus x sine y, right? So what is this? Cos 90 degrees minus x. So we know this, but let's just do the cast diagram just so that we're not making mistakes, unnecessary mistakes. So 0, 90 degrees, 180 degrees, 270 degrees, 360 degrees. So and cos of 90 minus x, 90 minus x first quadrant, so that would be, and since it's 90 it changes to sine x cos y. This is a negative angle, so it'll be minus sine x, but this is negative because it's in the third quadrant, so it would be plus sine y cos x all over cos x 360 plus, so 360 plus goes to the first quadrant, so this is positive, cos y. 360 minus is in the fourth quadrant, so that is minus sine of x sine of y. What do we know about the first identity? This equals to sine x plus y all over. So if we check our information sheet, it's plus, right? So sine x plus y all over, and if we check our information sheet, this cos minus sine equals to positive, so cos x plus y, and that equals to tangent x plus y. So yeah, really nice. 6 marks. That's a lot of marks, but maybe it's substitution, maybe it's other things. You will never know. You'll never know. I don't know the marking system. I'd like to know how they mark. It would be really nice to finally see the mystery. So given function f at x cos the square root 6 sine squared x minus 11 cos 90 plus x plus 7. Solve for x in the interval of 0 is an element, x is an element of 0 till x equals to 60 if f at x equals to 2. So just just write that down. So f at x equal to the root of 6 sine squared x minus 11 cos 90 degrees plus x plus 7. So dealing this with 2, we'll have square root of 6 sine squared x minus 11 cos 90 degrees. Okay, so 90 degrees plus x is negative cos, but it becomes plus sine because of that minus right there, so it'll be plus sine sine x plus 7. So if we square both sides, we're gonna have 4 equals to 6 sine squared x plus 11 sine x plus 7. So what I'm gonna do is use u. I use substitution. I think it's a u substitution, but the thing is, u substitutions are used in calculus when you solve like differentials, like tough differentials. But yeah, so I'm gonna use a u substitution and say u equals to sine x. So that means it would be 6u squared plus 11u plus 7, and then I'm gonna go minus 4 goes to 0. 6u squared plus 11u plus 11u plus 3 equal to 0. So this is a pretty easy substitution. We're gonna have 3u, 2u, and we wanna multiply that by 3 and then multiply by that 1, and that's so kinda lost somewhere there where this has to be positive. Like that. There we go. Therefore u equals to 1 over 3, negative 1 over 3, or u equals to negative 3 over 2, right? And therefore sine x equals to negative 1 over 3, or sorry, I almost said cos. Sine x equals to minus 3 over 2. Therefore x equals to arc sine minus 1 over 3, or x equals to arc sine minus 3 over 2. Sine can never be over 1. This is 1.5. So this solution is inverted. Therefore, x equals to arc sine 1 over 3. This solution is invalid because if you remember a sine graph, which this is, a sine graph can only go between minus 1 and 1. Minus 1 and 1. It can never go above those values. So if any value is over 1, then it's gonna give you that. And we can check this by, I have this right here. I don't actually know how to write arc sine on Octave actually. Okay, maybe next time, but we're gonna use this to do some proof checking. So yeah. 10 of that, add another layer, and doing 6.3. So 6.3, consider the graph g at x. G at x. We're gonna do some proofing for this one too, but yeah. G at x equals to 4 minus 8 sine squared x over 3. Calculate the maximum value of g. The maximum value of g is when this, so we have where sine, on the graph of sine, where sine peaks and drops and peaks and drops, but when it's sine squared you only get something like this. So you'll never have a peak and drop and peak and drop. So but you still are gonna have oscillation. So what's gonna be sine squared x is always greater than or equal to 0. So it's between 0 and 1. Yeah, let's see. Smaller. Okay, yeah, let me just write them properly. I guess, yes. It's between 0 and 1. It can never be below 1 because it is squared. Squared values don't tend to do that unless you're going into the imaginary numbers territory where this equals to square root of 1. But I don't think that's in curriculum. So ignore that. Ignore that. I used to say that to people who I used to tutor. So we know that sine peaks at 90 degrees, and we also know that sine is the lowest at 0 degrees. So at x equals to 0, g to the 0 equals to 4 minus 8 sine squared of 0 over 3. That equals to 4 over 3. At x equals to 90 degrees, for the demonstration I'm going to be using radians. So 90 degrees in radians is half pi, and here also I'm going to be using radians, so it's 0 to pi to do proofs for that. So add g to 90 degrees equals to 4 minus 8 sine squared, sine 90 degrees squared all over 3, right? This equals to, this is 1, so minus 4 over 3. Even if we had 270 where sine is negative, because it's squared, that's the thing. So the maximum value of g, is g to the 0, which equals to 4 over 3. And then what was the next question? Write down the smallest possible value of x for g with maximum. So write the smallest type of value with x. So now we're talking about x an element of, you can write it in many ways, but this is what they're saying, 0 but not equals to 0, but can be equals to 360 degrees. So write the smallest possible value of x. for that. Smallest possible value of x is x. That's it. That's the smallest possible. It's anything greater than 0. So it'll be 0.00000001, but anything that is greater than 0, that's the smallest possible value, because this is excluded. So yeah. Great. So we're gonna put these two diagrams into Octave. So I'm gonna start. Let's start with the first one. So I'm just gonna write it down and see you on Octave. So graphing this on Octave is super easy. This is a free software you can download, and yeah, you have all you need. It has your documentation, all that. So it's like coding. If you wanna introduce yourself to coding, and you can do this. You can do Mathematica, Python. There are a lot of softwares out there that are free. PyCharm, they are free, that could help you with coding. So let's do the first one. So I'm gonna graph g at x first because it's the easiest one. So so comments here are not like in Python. In Python, when you comment, so commenting is like you're just saying what you're doing. It's not gonna run in the code and you're not gonna see them. In Python, it's a hashtag. Here it is a percentage sign. So yeah, so what we're doing is graphing g at x, right? So how are we gonna graph g at x? Well, we know that it's x is from 0 till 360 degrees, but this I prefer to use radians than degrees, only because most systems use radians than degrees. So 0 pi divided by, so this is the increment we're going by. It just determines how smooth the graph is. So I've decided 64 is nice. You could do 32. You can decide how, but like have a small number, but don't have like epsilon type of small number. And we're going it till 2 pi. And what we're graphing is g. G, where g equals to, from what we had is so this is the top, the numerator, and it's all divided by 3. If we check back, we're graphing this element right here. So it's gonna be 4 minus so I like putting brackets only because I don't want to make mistakes when writing these. So you see it has a sign D. That sign D is sign in degrees, but if you just write sign, it's gonna give you sign in radians. So we can still choose to do in degrees, but yeah, so sign I might run an error here, but sign I dot power of 2. So I think it does tell us when a bracket is missing. Other than that, you can then put your graph on ChatGPT, code on ChatGPT, to just make sure that it doesn't have any mistakes. But it's probably best to write the code before you go into ChatGPT, and to understand coding before you go into ChatGPT, because there's really no use on using ChatGPT without even understanding what you're doing. So we want you to plot that. You want you to label x. The x label will just be, so you put a string. So strings are like words that are gonna appear. And the y label should be the g at x. So g at x, and the title of the graph should be, so strings, it doesn't matter if you do double or once. So let's say graph check, and then I wanted to actually, I'm gonna call it k, the maximum value, because they ask for the maximum value of the graph that's possible. So k max, the max of g, which is gonna show, it's not gonna show, we can command it. When you put a semicolon, you're cutting things from showing. And so x min, I'm gonna just go u, and that is min, and that is I, because we called it I. So we can call it x, but I try to stay away from those type of things because they do tend to mess up with the code sometimes. So I'm gonna call this graph check. When you're not writing functions, when you're just writing definitions, when you're just writing definitions, you don't need to name it the same as the definition you're doing. So yeah, so it says min is that, but because we start at 0, it's giving us min as 0. If I start this graph at point 0, 0, 0, 0, 0, 0, 0, 1, right, and run it, the figure will still look the same. But now graph check. So if I say u, I'm gonna get that 0, 0, 0, 0, 0, 0, 0, 0.1, and if I say k, I'm gonna get that, which equals to, was it 4 over 3? Yes, 4 divided by 3, which equals that. So it's great. This is what we're gonna use for statistics, but I really want to show you how to actually input it into a calculator for it to work. But yeah, doing the second graph,